Hello, let's try to solve another Leetcode problem. 1254, number of closed islands. So we are given a 2D grid consisting of 0 and 1s, and we should know that 1 means water and 0 means the land. And we just want to return the number of closed islands. Yeah, so the definition of the closed island is the zeros surrounded by 1, so it's gonna be a closed island. So this is gonna be 1, this is gonna be another 1. So it is a 0, it is surrounded by 1. We can directly use the DFS to solve the problem. So we're gonna use two for loops. We're gonna check if it is a 0. Definitely it means this is an island. So we're gonna check the connected component. It's gonna be this area. This is gonna be 0. And then we're gonna check the four directions of the border of the 0. For example, this is 0, the four directions, this is 1, this is 1, it is okay. Yeah, so it is okay, so we're gonna count it by 1. So for this example, so this is a 0, but as you can see, the border go out of the range. Yeah, as this is a 0, but this 0 is at the border, because this is the last column, it's gonna be c minus 1. Yeah, so it means it is at the border, so we're gonna count it as 0. But for this 0, it is surrounded by 1, so we're gonna count it as 1. Yeah, so we can solve it directly by using DFS. So for here, we just need to check if this 0 is at the border, so we're gonna return a 0. But for here, if we didn't find any border of zeros, it means it is surrounded. Definitely, it is surrounded by 1. Otherwise, if it is not surrounded by 1, so it must go to the border. Because it is surrounded by 1, it means all those zeros cannot go to the border. So this is just the idea of how to solve the problem. Yeah. Now let's just try to use DFS. Yeah. So the idea is that we are having a grid like this. So if this is an island, it is not connected to the border. So we're gonna count it as 1. So for this one, it is connected to the border, so we're gonna count it as 0. Yeah. So we're gonna directly use DFS to solve the problem. Let me just copy some maybe because I need directions. Let me copy the directions from some other code. Yeah, maybe here. Yeah, definitely I need to have this R and C and directions. Let me just copy some code. Some random code. Yeah, so I need this R and C, and I need the directions. Now I want to solve it by using the DFS. So for R in range with capital R, and for C in range with capital C, the number of columns. So I'm gonna check. So if grid RC equal to 0, so I'm gonna check if it can be enclosed island or not. So I'm gonna plus equal to the DFS with this R and C. And finally, I'm gonna return the final result. Yeah, let me just prepare a result and also prepare the DFS. I think the hard part may be the DFS. Yeah. So for the DFS, definitely from the first position, the grid RC is gonna be equal to 0. So if it is 0, so we're gonna set the R and C equal to 1, because currently I will not use the weighted set, because if we can solve it in place, why not just solve it in place, just inside the grid? We will not prepare any actual memory. Yeah, now we're gonna have a condition check. So if this R equal to 0 or C equal to 0, I mean if it is at the border, or R equal to R minus 1, or C equal to C minus 1, it means it is at the border. So I'm gonna set a border value. This border value gonna be called has border. So has border gonna be yeah. Let me maybe use another. Yeah, let me just use has border. I just want to check if this 0 is inside the border. So I'm gonna check the yeah, this variable is not so good. Let me just use self dot is a closed island. Yeah, let me just make a long variable, make it more meaningful. So self.is closed island gonna be false. Yeah, because it is at the border. Yeah. Now we're gonna use the check the for directions. So for dr dc inside the directions, so we're gonna update the row and column r plus dr and c plus dc, and now we are checking if it is inside. So we're gonna run the DFS. Yeah. So let me just finish the column. Yeah, and check the grid. So if it is still 0 with this new row and new column, yeah, and for here it should be row and column, otherwise I'm gonna make a mistake. So we're gonna run the DFS, and finally we're gonna return 1 if self.is closed island. So if it is a closed island, so we're gonna return 1, else we're gonna return 0. Yeah, so this means from the beginning we're gonna set self.is closed island to be true. Yeah, so for here, so we just imagine if we find a 0 here, we just imagine this is gonna be a closed island, so we're gonna set it to true. We are not sure, but from here we're gonna check. If it is not false, definitely it's gonna be true, otherwise it's gonna be 0. Yeah, now let me just run it. What is wrong? Yeah, I forget to use or to check. Yeah, this is a math. I have to copy. I copied the wrong things. You know, sometimes I copy a matrix. It should be grid here. As you can see, now it works. Now let me just submit it to check if it can pass. Yeah, as you can see, it passed all testing cases, and it's pretty fast. And the time complexity is just m times n, the number of rows and the number of columns, and it is not a big number. That is why it is so fast. Yeah, thank you for watching. See you next time.